So I'm working for Toshiba now since 20 years. When we talk about the market of mechanical relays, you can imagine a mechanical relay is a switch, and in all electrical devices you need switches, so you can imagine there is a huge market. A photorelay, it's a kind of optocoupler, so it's an optical isolator. So on the input side you have a LED. The LED generates light. The light goes on a photodiode array, and the photodiode array produces a certain voltage and current, which then switches on and off a MOSFET, which is on the output side. So a photorelay, we call it also a MOSFET output coupler. So there are various names for this kind of photorelay. But the easiest word to compare it with a mechanical relay is photorelay or optorelay. So we as Toshiba, we have the big advantage that we are a semiconductor maker. We have a very long experience. We are making photorelays since more than 30 years. And we have all the technology in-house. So we make from LED, photodiode array, and some MOSFET. We are making everything in our own factories. And yeah, we have excellent package technology. I think Toshiba is known for making very good, very small, very reliable devices and packages. And of course, we integrate this all also in our photorelays. So customer can be sure that he have really high reliable and very good products. The advantages of a photorelay compared to a mechanical relay is a mechanical relay has a mechanical contact, so it has some wear and tear, and it produces some noise. And when you have a photorelay, it's silent and it's a semiconductor, so you have not this kind of mechanical contact. It is a long life product, it's maintenance free. So a mechanical relay you need to replace from time to time due to the wear and tear, while a semiconductor relay you can use for 100,000 hours of operation without replacing it. Another main advantage of photorelays, of course, is the size. When you think a mechanical relay, it has some coil and a mechanical contact, so it's relatively big. But a photorelay is only a semiconductor, so you can go for very small form factors. You can integrate these in very small packages. And that's why the size of a photorelay is much smaller compared to mechanical relays. So a typical application is a semiconductor test equipment, where you have test cards with hundreds of channels and where you need hundreds of photorelays on one board. And if you compare a mechanical relay and a photorelay, which size is less than 50%, so you can put twice of devices on the same area. In some cases, it can be even up to 90% difference in size. So in the last few years, there was a lot of improvement for the photorelays. On the LED side, we have introduced a new generation of long lifetime LED, which makes the photorelay more robust. There is no degradation. The lifetime is improved. The products can even be operated in a higher temperature range. So first generation of photorelays, you could use up to 80-85 degrees. But now the latest generation are specified up to a temperature range of 110 degrees. So they can be used even in harsh industrial environments. And then on the power side, also the MOSFET technology developed a lot. And today we can have relays which are switching power. So the biggest relay can switch up to 5 ampere. And in the previous generation, it was less than half. So there was a lot of evolution, especially also on the power side. that today we can address areas and we can replace mechanical relays, which was not possible a few years ago. A lot of customers don't have experience with semiconductor relays, so that's why they hesitate to replace mechanical relays by photorelays, because they don't have experience with this kind of semiconductor devices. But basically, from technical point of view, it's very easy to replace a mechanical relay by a photorelay. So we provide a lot of information and material. We have some evaluation board where we put a photorelay on a second PCB, so which allows customer to use the footprint or his design for a mechanical relay, and he can directly replace it by such an evaluation board with a photorelay to directly test it and make some experience. And then if he makes a new design, we give a lot of help. We have some design guides. We have an e-book where we describe in detail what are the key parameters of a photorelay. So, and we have a selection guide. So when customer know, okay, I use this mechanical relays, these are the important parameters, he can directly check for photorelay, okay, these are the important parameters, so this kind of photorelay is suitable for my application. When you think about photorelays and the applications, there are so many applications, you can't count all of them. But when you think in your home or in your office area, you have air conditioning systems, you have thermostats, you have security cameras which switch an alarm or a signal, office equipment like headset, you have modems, you have plenty of devices where photorelays are needed. In the industrial area, when you think today the battery monitoring, battery management system, so the storage of the electrical energy in battery systems is getting more important. And to manage this kind of battery systems and the battery monitoring, also it's done by photorelays. But also in typical industrial applications like factory automation, like programmable logic controllers, PLCs. So there is plenty of areas where mechanical relays are used today, which can be replaced. And of course, a big area is semiconductor test equipment, where you have plenty of relays on one test card, for example. And here, of course, the size of the photorelays is an important factor. And especially here also the noise of a mechanical relay. If you have hundreds of devices on one board, it's enormous. So here already semiconductor relays are used, and customer don't think anymore about mechanical relays.